Hi everybody, we're on our second set of notes related to erosion, and this one has to do with water. And water is by far the most important agent of erosion. It does most of the work shaping our landscape. It moves most of the material, and that's because we're a water planet. We have lots of water constantly flowing through the water cycle. Gravity is really important to this as well because it causes the water to flow downhill. It gives it the energy. And the more gravity change that you have, the stronger the force of gravity, the faster that water is going to be moving and the more erosion you're going to have. So if you have a big change, big drop in elevation, the water is going to be moving faster where it's steeper and not as fast where it's more gradual. That makes sense, right? And so if the water is moving faster, it can pick up and carry more stuff. So these sediments, if you remember from the lab, the whole lot of shaking where you shook those sediments up, that abrasion is where the particles are sanded or smoothed, and they become smaller, rounder, and smoother. You saw that firsthand in that lab. One of the things that I was just talking about, where you have water moving fast, is that helps to cause the particles get picked up. The faster it moves, the bigger the particles it can carry. So as that stream starts to slow down, the biggest particles settle out first. And we'll do some labs with that. And we'll talk about deposition, and we've got some notes on deposition as well, and we'll talk more about that. But the larger, rounder, more dense particles always settle out first. They're the first things to settle when a stream is flowing. And sediments carried in the stream tend to move slower than the stream itself. So if you can imagine a cross-section of land and a stream is flowing down, the stuff that's floating inside, that's suspended, is going to be moving with the stream, but it's going to be moving a little bit more slowly than the stream itself. So when that stream gets to a place, instead of being really steep where it's moving fast, when it slows down and it's in a more flat place, the stream doesn't move as fast, and so those particles start to settle out, and they settle to the bottom of the stream or to the bottom of a lake if it gets to into a lake. Okay. The ways in which sediments are carried in a stream, there's 4 different ways, and the first two in solution, so they're dissolved. Like if you think of halite, and we talked about halite a lot in that whole lot of shaking lab, but halite is just salt. If it gets dissolved in the water, it'll get picked up and carried along with it until that water evaporates and then the salt settles out. They can be suspended, which means that they're being picked up by the stream, but they'll settle out if it slows down. So if you think of sand and water, if you take a cup of water and you have sand in the bottom and you stir it really fast, it'll get all murky and suspended, and then if you let it sit, all those particles will settle out. That's a suspension. Particles will also do something called flotation, which is they'll float on the top. Think of a block of wood floating, or a piece of wood or a stick floating on top of the water. The water will carry it along, and it'll move from one place to another. And then the bed load is also something that it's called saltation, where the things aren't being picked up and carried, they're just sort of rolling around on the bottom of a stream. So as the stream is flowing, the biggest particles the water may not be moving fast enough to pick it up and carry it, but they'll roll along on the bottom of the stream. They'll just sort of be pushed along on the bottom. And as that stream is flowing, the particles get pushed at the bottom, and they're just bouncing and rolling on the stream bed. And you can imagine that as they're bouncing around, pieces are getting broken off, and that's part of that abrasion where rocks are rubbing into one another, bouncing into one another, and that's how they get rounded and smooth as water. It's not the water that's actually doing it, polishing. It's the other rocks that are hitting it and causing it to be sort of smoothed out or sanded. The when we look at streams, streams are any body of water with a current. This includes things like streams or tributaries or brooks or creeks or rivers. Those are all more specific versions of streams. And how fast the stream is moving, and we'll do a lab on this, but and if we've already done the lab, then this will be familiar, are two things called, one is gradient, or the slope, and we've talked about gradient before in class. The steeper the slope, the faster the water flows. So gradient is just the change over a distance, change in elevation over a specific distance. The bigger the change in distance over the shortest distance will give you a steep slope. So if you have a big change in a short distance, it'll be a steep slope. If you have a big change over a bigger distance from here to here, then that slope is more gradual. Okay, so you get gradual slope or steep slope. The steeper it is, the faster the water flows. And if imagine that you have a stream that has just a trickle of water, and then you have one that has a lot more water. The one that has a lot more water is going to be moving faster. That's called the discharge or the volume of the water. So that's also discharge. It's another word for the volume is discharge. Okay. The next thing is the shape of the channel, and let me just move this out of the way so that you can see what I'm talking about. The shape, what the stream looks like. If it's a straight stream, it's going to move faster. And that's just because there's no corners that it has to go around. And as it goes around a corner, that slows things down. So slower streams tend to meander, or yes. So when it's less steep, you tend to get these meanders. And a meander is just a bend in a stream. Okay, it's just a curve in the stream. And there's something really important about these meanders, and it has to do with where the stream is moving faster. So if you're going around the outside of one of these meanders, on the outside here, the stream is moving fastest right around the outside here. So we have greater speed out here, and because this has to go in the same amount of time, it's going to this distance. Okay, so you can see that if we start at this spot right here and we end at this spot right here, a particle that has to travel on the outside has to travel a much bigger distance than this one that's on the inside. And if it takes them the same amount of time, if you just imagine that it would take the same amount of time for it to go from here to here, from this line to this line, if you had to race somebody and you had to get there at the same time, this person that has to run on the outside has to run a lot faster. So in essence, on the outside of the stream, the water is moving much faster. And that has a huge impact on the dynamics in the stream. It has these. It causes the water to pick up materials on the outside, because faster moving water picks up materials, and slower moving water tends to deposit materials. So on the outside, erosion is taking place. Erosion is taking place where the water is flowing fastest on the outside. This all sort of goes together. Sorry that it's on two different lines. But basically, water flows fastest on the outside of the meander, and erosion takes place there. So there's erosion on the outside, and water flows slower on the inside, so deposition occurs there. And we'll talk about how that affects streams and the way streams look at another time. But just know that is one of the things, if we haven't covered that yet, just try and remember that when we get into talking about what the profile or what the shape of this stream looks like. So that's it for now. We have one more thing. Sorry. The largest sediments, if a stream has a lot of large rocks, they'll slow down the flow of water. Material in the stream, as I said before, moves slower than the water itself. So if you have big rocks in the stream, that tends to slow the water down. Smooth stream channels tend to flow faster. So there's less stuff for the water to go around or bump into. So that's one of those, one of the things that also tends to change the speed of a stream. So I think that's it for now for these notes, and we'll continue to talk about streams in class, and we'll do some labs and some demonstrations to show you that stuff. Have a great day.